You have successfully added static firewalls to your AI agents. You have stopped immediate injections and you have hidden raw PII. But once your LLM application scales to thousands of active production users, how do you know if your model's alignment is drifting? How do you catch silent toxic responses or maybe sudden spikes in adversarial attacks or subtle linguistic hallucinations over time? Standard network or infrastructure monitoring won't save you here. You can't use standard telemetry tools to track whether your LLM is suddenly turning hostile or leaking internal brand data. To truly run enterprise AI safely, you need real-time LLM telemetry. Welcome back to our Agentic AI Security series. Today, we are diving deep into LangKit, an open source, OpenTelemetry-compatible text metrics toolkit created by WhyLabs. We are going to do two things over here. First, we'll implement LangKit standalone in Python to extract granular security, toxicity, and injection scores from raw text. Second, we'll wire LangKit directly into a LangChain Callback Handler to intercept, profile, and stream real-time security logs asynchronously right as of our agent handles production tasks. Let's jump into the environment. LangKit works by compiling text into localized mathematical snapshots called data profiles. And this is done via our underlying library called WhyLabs. Because these profiles are generated entirely within your local memory workspace, your user's raw data never leaves your secure environment, making it fully compatible with strict enterprise data privacy rules. Let's spin up our workspace dependencies. Pop up your terminal and run the following command to grab LangKit's comprehensive metric modules. Pop open your terminal and run this command to grab LangKit's comprehensive metric modules, LangChain, and our native Google GenAI SDK. Now let's create our workspace files. We'll start by looking at LangKit standalone to see what kind of security telemetry it can extract from our prompts and model responses. Let's create a quick script. We'll initialize LangKit's core text modules, which download optimized lightweight scoring models directly onto our local systems. We'll use this to analyze a toxic prompt and a secure response. To build an asynchronous, non-blocking pipeline monitor, we'll subclass LangChain's base callback handler. This allows us to catch lifecycle events, like when an LLM finishes generating text and cleanly extract our telemetry parameters without delaying the user's response time. The method on LLM end triggers automatically on lifecycle generation completion, and it ensures monitoring processes are observer only and never block user execution. Here is our secure monitored agent. We are again using Gemini 2.5 Flashlight as our model. As you can see, there are two test runs. One is evaluating a highly aligned standard corporate request, which is to generate a standard, highly polite out-of-office auto-reply message for a software developer. While the second one is evaluating an adversarial attempt to create a metric shift. Now, let us run the script and observe the results. The agent generates output normally, and right in the background, our custom LangKit telemetry callback intercepts the generation lifecycle events and profiles the text distributions locally and compiles the logs, all without adding any operational overhead or latency to the user's front-end application interface. Let's look at the responses. The highlighted response is for the safe out of office which was run 1. The response reading is 61.02. A score in the 60s indicate standard, structured and professional corporate language, roughly an 8th to 10th grade reading level. It is tightly aligned and structured. The run to is adversarial rant and the score here is 69.38. The score jumped upwards towards 70. In the flash reading ease index, higher number means the text uses smaller and shorter sentences. These sentences are simpler, punchier, and conversational vocabulary. Gary's furious conversational shouting, now, garbage, look, drastically altered the linguistic signature of the model's generational layout. By pairing the real-time input filtering of LLM Guard from our last video with the continuous telemetry tracking of LangKit, you build an AI application stack that is secure against sudden attacks and it is fully monitored over time. I have uploaded this pipeline monitoring.py script to our master playlist GitHub repository linked down below so you can deploy it straight into your MLOps pipeline. If this hands-on monitoring deep dive helped demystify LLM telemetry, then please support the channel by hitting the like button. Please subscribe to Tiny Tech Talks by ML and drop a comment below with how you are handling AI observability in production. Stay secure, keep coding, and I'll see you in the next security architecture breakdown. Thank you.